Okay, folks, here we are with hot topic 10. Now, just a couple of very quick things. We need to be able to distinguish between immediate and short-term effects, and we're going to do that in a few moments' time. But let's get straight to the nitty-gritty here. We need to look at sort of very, very simple question structures where we identify, not that use of identify, but we notice that we've got to make those 3 points to get those 3 marks. Each of those is going to be that discrete individual element. And what I want to show you here is perhaps what might actually happen here with both your answering and also with what an examiner is going to do with the marking of your answer. So we're obviously looking here at immediate effects of exercise. That's this grouping here. It's just below on the paper if you want to have a look at here. So I'm going to say here, increase in temperature. Now I really should say muscle temperature there because core body temperature doesn't actually go up typically in exercise, but I'll keep it increase in temperature, increase in breathing rate, and I'll come back to that point in a few moments time. Increase in breathing rate and I'm going to put in here increase in heart rate. So you can see here I've effectively got 3 increases. You can obviously just say increase in temperature, breathing rate and heart rate if you prefer, and increase in heart rate. But I just wanted to emphasize that point, and really all I want to do at this particular moment is just to sort of switch to red pen and go, look, when your examiner is marking this, they're going to do it on screen on a computer, by the way. I'm just doing it effectively with the pen here. But what they're going to do is they're going to take the key language, they're going to highlight it, I'm circling it, they're going to tick it, and that's going to get you a mark over here. Just like here, increase in breathing rate, it's going to get you a mark, an increase in heart rate, it's going to get us a mark. Now that's obviously a very, very simplistic question, and we hopefully get a max of 3 marks over there because it rates to this point here. Now, before we move on from that question and look more generally, I just want to make a little bit of a teaching moment here. Increasing breathing rate is something that we should be aware. Let me just change pen color to something more general. If we talk about breathing rate, so if I put B rate, breathing rate, this goes up during maximal exercise. Okay, now maybe you want to sort of notice this next time you go and play your sport, whatever. Your breathing rate won't go to until you're really working hard. Whereas breathing depth, breathing more deeply, tidal volume going up, that kicks in at the start of exercise. Okay, so it's only at top levels exercise that we get faster breathing. And I could go, I'm not going to get into the mechanics of this today, but breathing depth does go out. So I'm mentioning that because we just need to be a little bit cautious with this one here, increasing breathing rate, because increasing breathing rate only happens in some kinds of exercise, not in all kinds, whereas breathing depth is in all kinds. I just wanted to mention that just in case there's any confusion or uncertainty. Now, what we've got here, and really I just want to create a distinction in your mind. You must be able to identify questions that are talking to you about the immediate effects and the short-term effects. Immediate effects are during exercise. Short-term effects are the day and a half after exercise. Okay, so that's what we're talking about here. So we've got hot, sweaty, red skin, increase in depth and frequency of breathing. There's a depth that happens with all, frequency or rate happens at maximal, and we've got increase in heart rate. By the way, there are other things too, okay, but we will keep it to those simple points. What we would expect to happen 36 hours, or up to 36 hours potentially, is we might feel a bit woozy. That can happen. Actually, it happened to me yesterday. I did a big treadmill session yesterday, and afterwards I was, whoo, that's I can feel that. My legs didn't quite feel underneath me. You might get that little sense of sickness. By the way, I often think another way of saying this is more of a sickness point, but have you noticed how appetite can actually go down sometimes because you're exercising regularly? Have you noticed this? An individual session can make you hungry, that's true. But actually, exercise and appetite suppressor. But anyway, that's a whole other conversation. We might get delayed onset of muscle soreness. Just remember that we refer to that as DOMS, that's that aching. And we might get sort of, I like to say here, localized tiredness and fatigue. Again, we're talking about in sort of parts of the body there. We generally find that activity is an energy provider to the human body. It will give you sort of more of a sense of vibrancy and energy. Okay, so if you need more time at this point, obviously feel free to do so. What we're going to do is we're going to have a look at this question here. It's asking me to describe 3 short-term effects. So this is now from that yellow grouping that I had on the right-hand side of the page just a moment ago, and you've got just above, okay? So what would we expect to happen here? We're going to say here, you may feel lightheaded. And again, I'm looking for 3 here, folks. So I've got to use all, I've got to make at least 3 points to get to this. You may feel lightheaded, suffer from DOMS. That's the delayed onset of muscle soreness. Now, no one's ever told me not to use the acronym, so I'm going to use that here. In fact, I tell you what, I'm just going to do good practice. Let's put it in there. Should have done this the other way around with the DOMs in the brackets. Delayed onset of muscle soreness. We don't want to lose a mark, right, because we've written DOMs. I'm sure DOMs would be fine, but I'm just going to make absolutely sure. Why leave that in my head if I know it? Or experience fatigue. Now, it might all seem very, very simple to you folks, and you might be thinking, well, that's really obvious because we've just sort of translated it from the image above. But the point I want to get early in the session here is what's going to happen here. I think I've gone for something that's pinker than red here. Here we go. So we're going to get lightheadedness, circle, tick, 1 mark, DOMs or delayed onset, circle, tick, 1 mark, experience fatigue, circle, tick, 1 mark, or the equivalent that your examiner will do on the computer. So notice the relationship between the answer I've given and the number of marks and the fact that I'm not being asked to explain this or take it further. I'm just going to do things, excuse me, up to that limit that I'm required in this particular case. Okay. Okay, folks, we are making progress. Just a very quick question to begin with. We had it as one of our MCQs, multiple choice questions. Which of the following vessels transports oxygenated blood to the body? Okay, so we've got 2 facts there that mean that only one of these answers is correct. Now, I'm going to start from the bottom. The pulmonary vein cannot be correct because first of all, it comes back to the heart, in fact, to the left atrium. And it contains, albeit it does contain. So the first bit is correct in terms of the oxygenated blood, but it goes to the left atrium. The vena cava comes back from the body. It contains deoxygenated blood, so it can't be that one. This one can't be either because it goes back. It's coming from the lung to the heart. It can't be the pulmonary artery because first of all that contains deoxygenated blood. And also it goes from the heart to the lungs, so it can't be that one. Whereas the aorta, it contains oxygenated blood leaving the left ventricle, we'll look at that in a second, and it's going to the body. So of course, this one here is the answer. But just notice this one's kind of trying to trick us a little bit, but this one here is the answer, which we'll see in a moment. So, not an easy question, but albeit 1 mark, things picking those up. Now, I'm just going to try something here, folks. Just bear with me. I just want to zoom in slightly so we can see this whole thing. I'll zoom back out afterwards, okay? Just want to make sure that we can see this whole thing on 1 page. So what I want to do here, folks, is I want to introduce you to somebody. And this somebody, we're going to refer to this little item here. We are going to call this Reggie. Okay, Reggie. He's Reggie, and he is a red blood cell. Okay, now you can use whatever name you like, but it must be alliterative. It must be an alliteration. Reggie Red. Okay, so that's why I've gone for it. And what we want to do here is we want to start to kind of be able to identify the pathway of blood around the heart. Now, my red blood cell, you think, well, it's not red, James, it's blue. That's because at the moment it's deoxygenated. Okay, and we'll come to that. But what we've got here is we have got a vein which is running back in to my right atrium. I know it looks like the left, but you've got to look at it as if this person's looking at you. Here we have got the vena cava vein, okay, and that is running back into this space here. So even though we can't see it very well, my red blood cell, which is blue, and we'll just do it slightly here. He's kind of coming in here. Look, he's coming in here. He's coming in here, and we can't. I've got to sort of do it in white because then you can see it better on the blue. And what's going to happen is he is now sitting there, just very temporarily, and he is sitting, as you can see here, in what we would call the RA, the right atrium. Let me write it over here for us. We have got here the right atrium, okay, the right atrium, which is that opening, that entryway into the heart. Now, our blood vessel, what it's going to do, through what we call atrial systole, more of which in a second, it's going to get pushed down, and it's now going to be down here. And this is now in what we call the right ventricle. So we've now got the right ventricle. I'll write it in so you can see it on the actual image. But my right ventricle is just there, and I'm going to put it into white. So it's just here, look. It's here. So we've now got our right ventricle just there. And it's worth noticing as well that this thing here is a valve. Now, I'm not going to name it the tricuspid. Oh, I did it quite. I'm not going to name it here, but that valve, the idea of that is that in a moment when the heart squeezes systole, it's going to force the red blood cell up and out of the heart, and it prevents this red blood cell going back into the right atrium. So what's going to happen now, guys, is the heart now is going to start to contract. It's going to contract like this, inwards and upwards like this. The heart contracts like that. And my blood cell, which I'm just representing white at the moment because it's on the blue, it's going to go up here, up here, up here, and it's now going to go into this artery. And this artery here, folks, is called my pulmonary artery. Okay, so there's my pulmonary artery right there. And obviously we would have it coloured in blue normally because it's all deoxygenated, going up like that. And my blood cell is going to come through here, through here, through here, through here. And let's just say it squeezes through this capillary, okay, this capillary here. As it squeezes through there, we're now going to turn it red. And why is it now red? It's now red because it's oxygenated and it starts returning back to the heart like this. And it's doing that through the pulmonary. In fact, I've chosen quite a good red for this because it's quite crimsony. Maybe it's a bit pink. But this thing here is the pulmonary vein. The pulmonary vein brings that blood cell back. In fact, I'm going to go for it into sort of very light colour so you can see it's still not white. So it's going to come back into here, into here. And of course, what have I got now? I've now got my left atrium. Okay, so my left atrium is there. That blood is then going to be squeezed down through another valve into the left ventricle. The left ventricle. And of course, that is happening just there. There's my left ventricle. And when that left ventricle contracts, which is going to contract here, 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 this blood cell is going to get squeezed up and out of this vessel here. Going to get squeezed up and out. And that vessel there is called my aorta. Okay, and that aorta is going to bring that red blood cell, Reggie, round into my body. It's going to go past a muscle tissue here, let's say in the quadricep, and guess what's going to happen? It's going to become deoxygenated again, and it's going to become blue, not metaphorically, not literally, and it's going to re-enter eventually the vena cava, and we are back on the journey. Now, just two other things I want to mention to you here. Can I stress to you, there are valves here, here, okay, but there are also valves here and here in the exit point of the heart, the entry point of the two arteries. Can I also remind you that this up here is the capillary bed for the lungs, and we would just call this capillary bed down here the body, but really we're interested in that being the muscle. Okay, now, one of the nice way to think about that particular process, I'm going to zoom back in now, just bear with me a second. I want to go back up to my 100% so we can see. There we go, about that. So, one of the nice things to realise here is the terms I use, which are systole and diastole. Systole is when part of the heart is contracting and it is sending blood out. So actually, you might want to notice that the atria, the two atriums, they contract, forcing blood down. That's called atrial systole. And then they relax. That's called atrial diastole. And they have to be relaxed because we're then going to get the ventricles contracting and forcing blood up and out. Meanwhile, the atria are relaxing and filling again. Okay, so relaxing and filling is diastole. Systole is ejecting and contracting, which is why I use that terminology. Now, I've pretty much done this activity for you. I basically messed up. I meant not to put this order on the page for you, but I messed it up and actually included it. But the point I want to stress to you here, folks, is you absolutely must, when you're describing this process, you must say where the blood has come from, what it has passed through, and where it has gone to. That is the technique we want to use. So, for example, at the very start of our journey, I just did above, the blood came from the body, including the muscles. It went through a vein. That vein was actually the vena cava. Let's be specific. I shouldn't have done that in red. It's the vena cava, and it goes to the right atrium. That's the first part of the journey. Now, the second part of the journey is from the right atrium through a valve to the right ventricle. That's the second part of our journey. And you can follow that sequence and that order to show you the exact description that I just drew for you above. Now, I'm not going to write this whole question for you because you can do this, I'm sure, by yourself, and your teacher's got it already. But I just want to sort of start writing for you, and then you can maybe finish it off. But I'm going to say here, for our question, deoxygenated blood, and look at what I'm going to write here, folks. Deoxygenated blood travels, and they're asking me to start at the right atrium, by the way. Goes from the right atrium through a valve and to the right ventricle. Now, of course, my second statement is going to be something along the lines of it then goes from the right ventricle through a valve and to the pulmonary artery. And I can just keep doing that again and again. So at the very end here, I end up with my last statement, which is going to be something, I won't write the whole thing, but it's going to be from the body through the vena cava to the start point, which for us was the right atrium. And I just want you to use that technique, folks. The technique is that one. From something, through something, to something. That will serve you beautifully when you write answers on this topic in your exam. And we highly recommend, I don't know why I've got something beeping, I thought my computer was on silent for me, I apologise for that. But that's what we want you to do, and teachers, we encourage you to guide your students to that end piece. Okay, levers, another of our mechanical topics and one of everyone's favourites. So we've got an example here. Long jumper at point of takeoff and identify the class of lever at the ankle. Now, obviously, you might just remember that this is a second class lever, but I would like to prove it to you if you don't mind me quickly doing so. So here's my ruler. I always have to do a little accent with my ruler. I don't know what I'm going for here. It might have gone a bit Welsh, I don't know why. Anyway, bizarre. No offense meant 21. But look, guys, there is the lever arm of my lever. Okay, so I'll get rid of that now. Then what I've got here is I've got a fulcrum, which is just here. Okay, the weight of the body, or in other words, the resistance, the load is just there, and the effort is here on the gastrocnemius, or the tendon of the gastrocnemius. So of course, what have I got in here? I've got a second class lever because my load is between the other two components. So therefore, I've got a second class lever system. Now, if you need to draw over in order to establish that, by all means do so. Obviously, that would be ticked and would get me 1 mark and will get me a max in this particular occasion. But we've got some other examples here. We set up one of our mock questions like this, which was, by the way, the reason we set up like this is because we can't actually have you drawing on our website to answer the exam questions, but we are working on that. But here we've got describe the position of A, B and C for the class of lever at the ankle during a long jump takeoff. So obviously that for us was our second class from earlier. So what did I just say it was? Well, we had the lever arm like this, we had the fulcrum at the far right hand side, we had the resistance or the load just there, and we had the effort in there. So if we had fulcrum, if we had load, and we had effort, then as long as I was to describe the relative positions of all three of those things, then obviously I would get that right. So we asked you to describe it in the question, but in reality we think you'll probably have to draw it. So again, we just sort of mirrored that question out. So let me actually kind of do this properly for you. So what I'm going to do, just like you would do, is I'm going to get my ruler, do it not just freehand, but do it correctly. So I'm going to use this, and I'll do it all in black because you will have a black pen in your actual exam. So this is what you would do. You would draw your lever arm, a nice straight line like that. I know the fulcrum is at this end, so I'll draw my fulcrum. And you could put your F in there, but I'll just put it underneath. There's my fulcrum. In fact, I just want to be sure, so I'll write the whole word in there for me. Now I know that the load here is in this position, so this is my load, and of course in this case that's the body weight of the jumper, and here is going to be my effort, and I would draw it in this way. So if you notice, folks, it's almost like it's only for 2 marks this, by the way, but if you actually notice, there's 4 parts to doing a drawing of a lever. What are they? We've got to draw the lever arm, we've got to draw the fulcrum, we've got to draw the load, and we've got to draw the effort. So as long as you're putting those 4 in the right order, in the right proportion, then you're going to pick up all the marks that you need to on a question like that. So just remember that levers, we tend to say they've got 3 components. In reality, they've got 4 parts because we need that solid rigid bar, which by the way is normally a long bone in the body. This would be the tarsals and the metatarsals of the foot, of course, and the phalanges on the end. So this is what this lever arm actually is. But we need those 3 components in the correct order in that way. So I'm going to choose a nice, easy one, make life easier on myself. I'm going to choose that. I'm going to choose that 3rd class lever in the elbow. And what I'm going to do here, I'll get you to draw it here, but I'm actually going to draw it over the performer just so you can sort of see it in context. I encourage you to actually draw it in the space provided. But I'm going to draw my lever arm. There it is. Of course, this is going to be the forearm. In fact, specifically for this, there's actually the radius specifically. I'm not going to get too deep into that. And of course, what have we got? We have got the fulcrum, which is the elbow. So I've got my fulcrum just there. Down here, I've got my load, which of course is the weight of the dumbbell. You could also argue the weight of the forearm as well. And then up here, I have got the effort, which is the contractile force of the bicep pulling upwards. And of course, we're assuming this person is rotating their elbow in this direction. Of course, that is movement through the sagittal plane or around the transverse axis. It is flexion of the elbow. The bicep is the agonist of this movement, and this is actually anti-clockwise movement if you look at it carefully. So that, because the effort is between the other 2, that of course makes that 3rd class lever system, okay? So it's nice for us to be able to do that. So you want to be able to draw those things in. So I've chosen that one, by the way, sorry, I should be clear, that one would have gone into here, I should say, is the 3rd class. Let's do a different one. Let me do my 1st class one now. Let's do the 1st class one at the, this would be this here, okay? So is the elbow extension. So imagine that I've got a lever like this, okay? This is from my 1st class one. So I've got a lever like this. I'm just freehand drawing it now. Okay, what I've got at this point is I've got a fulcrum, which is here. So there's my fulcrum, sort of slightly doing the side here. So I've got that there. But what's interesting about this one is that the effort is right on the point. So the effort is there. And of course, the load is up here. The load, the weight is up there. So what have we got between this time? In between the other 2, we've got the fulcrum in the middle. Now, you might be wondering, what the hell is the effort on the end? If you feel the point of your elbow, guys, and you sort of extend your elbow, I might be showing this on camera later on, but you've actually got the insertion of or the contact point of your tricep muscle is right on the point of your elbow. So it's just outside the actual joint itself like this. And just imagine that the javelin is this red line I'm drawing. Imagine that the javelin is here, okay? This person is about to launch this javelin in that direction, okay? So that's what's happening here. So by pulling here, it pulls that in this direction. And of course, what is that? That's elbow extension. And the 2nd class you've already had me do, so I won't do that one again for you. Okay, don't forget your mechanical advantage, folks. This is really, really important for you, okay? So just remember these things. If the effort arm, and I'll quickly confirm what that is for you, if the effort arm is longer than the load arm or resistance arm, this causes mechanical advantage, okay? So let me just be clear. This here, from this point, perpendicularly to this point, that is the effort arm. And can you see how that effort arm is longer than this difference, which is the load arm? So the effort arm is longer than the load arm. It causes mechanical advantage. Okay, now that mechanical advantage, what it means for is this example here, we can do large loads. We can do large loads with little effort. So what a surprise that at the weight-bearing ankle we get mechanical advantage. However, if the effort arm is shorter than the load arm, that causes mechanical disadvantage. Now, one thing we say about mechanical disadvantage is it doesn't allow large loads with little effort. So you can say it like that, but it does allow for speed. It does allow for flexibility of a joint. Okay, so mechanical disadvantage is not necessarily advantage, it's just we need it in different places, and that's why levers are specialised, joints are specialised. And remember, for 1, 2, 3, think FRE or FLE. For 1st class, think F between the other 2. For 2nd class, think resistance or load between the other 2. For 3rd class, think effort between the other 2. So this has got the resistance between the other 2, the load between the other 2. So of course it's a 2nd class lever as we've looked at already.